Now imagine you were to tell a loved one, hey, I got a great idea. I'm going to buy a motorcycle, drive at 120 miles an hour down the freeway without a helmet, and get in an accident. They might say, I got a better idea. Why don't you just get a car with airbags and use your safety belt and we'll go the speed limit? Now, that's because they want to keep you around. They don't want you at risk. What they've just done is similar to an instead of trigger. They said, hey, instead of being crazy on a motorcycle, why don't you just get a car? Does that mean you're going to get a car after you get a motorcycle? Or is that instruction set of getting a car going to happen instead of getting a motorcycle? So this comparison is like the difference between an after trigger, which runs after a statement has been made, or an instead of trigger, which the statement that was issued that caused the trigger to fire off never runs. Only the code in the trigger runs. The DML statement won't run at all. Okay, that sounds pretty conceptual, so let's give you an example of how each type of trigger works. Let's say create trigger TGR del employee history. Now, why am I creating this? Because you are not allowed to change the historical records of one of the archive tables. So what I want to do is make sure that if somebody attempts to delete a record from the employee history table, that doesn't happen. Now, if we were to use the after trigger example from the last chapter, it would look like this. We would say, okay, let's go ahead and roll back the transaction so it never happens. Let's run this statement to create this trigger. Now, when we attempt to delete a record from this table, it's going to stop us and give us an error message. So let's just try to delete one record from the employee history table. Let's run this. Notice this message, error, level 16. The transaction ended in the trigger. The batch has been aborted. Okay, it stops you, and you get an error message. The delete DML statement actually ran, got to the intermediate state, and right before it committed, we rolled it back. Okay, great. Delete statements from the employee history are being rolled back so they never actually quite make it to permanent storage. Excellent. But if we never want this to happen at all, why are we allowing the delete to run and then undoing all of its work? Like if I didn't want you to buy a motorcycle, why would I say, okay, why don't you buy the motorcycle as soon as you get it, but before the check clears, let's return it, fight them in court. That's pretty messy. If we know you're never supposed to own a motorcycle, why don't we do something instead of buying one at all? Well, let's get rid of the existing after trigger so we can recreate it more efficiently. Let's drop the trigger name TRG del employee history, and let's run this statement so the trigger is no longer there. Okay, now let's create a brand new trigger similar to the other trigger, and we're going to use the same name, except we're never going to allow the delete to be run at all. And we're going to do this on the employee history table, and we're going to say instead of delete as, and then begin and end. Now, between the begin and the end, I don't need to roll it back. You know why? Because instead of deleting, it never happened. It's going to run whatever code I put here. And instead of throwing a level 16 error message, why don't we print a little friendly message that says print historical records are never to be deleted. Let's run this. Commands completed successfully. When we attempt to delete, the delete never takes place. No error message happens. It just says historical records are never to be deleted. Although it says one row affected, that row was just the memory resident deleted table. We're going to explore a really handy use of instead of triggers. Before we do this, let's create a brand new table. Let's create a table we don't really need, but it's good to test out. A table called test. And let's make the first field an integer, and that field will take care of itself. It'll be an identity field. We don't have to pick the value upon insert. The next field will be called test name, which is a varchar 40, and we will insert that value. Finally, we'll have a third field called creation date, which is a date data type. Okay, let's create this table. Commands completed successfully. Now, let's insert into this table the following values. We have 3 fields, but we only need to supply 2 values because the first field is an auto-generated identity field. So the test name field will be called field test, and for the creation date, let's put an outdated date of 1/1/2005. This comes from an external feed, which always feeds us 1/1/2005, and it's our responsibility to update it later. Let's run this insert statement. 1 row is affected. Let's select from that table. And we see test ID 1, which was auto-generated from an identity field. In the second column, test name, we supply the value field test. And it was done on January 1st, 2005. But it really wasn't. We did it just now. So let's update and set the value to the getDate function where the test name is equal to field test. That should fix that feed. Let's run this. 1 row affected. Excellent, we got a modern date here. Now, why didn't we just feed the correct date up here? Let's say we're not in charge of that feed. That feed is coming from a C# calling application that we are not allowed to touch or change. So whenever it comes in, we have to run the second update statement just to make it correct. Now, let's insert another record, a second record, and let's use the following values. Let's call this a row test. And again, we're stuck with this feed of 1/1/2005 that we have to change later. Now, if we could change the C# code that's feeding us, well, then easy peasy. But if we're not allowed to, here's what we can do. The C# is sending us this DML statement as it is, and you can't change it. But you want to intercept it and ignore the 1/1/2005 value and pass the current time in instead. Okay, how do you do that? Well, let's create a trigger called trg_insert test on the test table, and instead of inserting that old value, we're going to insert the new value. How? We'll start off by writing a select statement that gets just what we want and inserts the current date. But instead of the time that was inserted up here, we're going to go ahead and put the getDate function from the inserted memory resident table. Now, let's insert these values into the test table. Run the create trigger statement. Commands completed successfully. Excellent. Now let's insert this record. It says 1 row affected twice. Now let's go ahead and select from the table. Run a query from the table, and you'll notice the record was inserted as specified, except the creation time was the new date. Well, we learned there's a lot of different activities that can fire off a trigger. An insert can fire off a trigger, an update can fire off a trigger, and a delete can fire off a trigger. So what if we wanted to prevent inserts, updates, and deletes to the stateless table? You can't update that table in any way with any DML statement directly. Well, you could create a delete trigger, and then create an insert trigger, and then create an update trigger. Or you could create one trigger that's looking for all 3 events. Let's do that. Let's say create trigger trg instead state list, and we'll do it on the state list table. And instead of insert, comma, delete, comma, update, we're going to do what's between the begin and the end. Now here we're just going to say print no changes are to be made directly to the state list table. So instead of any of those actions, you'll just get this message. Okay, let's run this. Commands completed successfully. Now, let's see what happens if we delete the stateless table. Can we delete any records? Nope, no such changes were made. And if you were to run an update or an insert statement, that would fail too. Lab 3.1, Skill Check 1. Create a trigger called trg_del pay rates history on the pay rates history table that shows the message historical records are never to be deleted instead of actually performing the delete action. Skill check 2. Create a trigger called trg_insert employee history on the employee history table that shows the message insertion of new records to the employee history table must take place by inserting to the employee table. Skill check 3. Your management training table has the CK_management training_approved date constraint, which disallows dates prior to 2006. The calling application has been traced using the following code and is getting the error message you see here. You are not allowed to change the insert statement, but you need to insert the current time in the approved date field. Create the TRG insert management training trigger to use the getDate function instead of 0. Run the insert statement and query your management training table. When you're done, your screen should resemble the figure you see here.